Okay, so today is 8.3. The name of this lesson is period and frequency. And so for today, just like 8.1 and 8.2, you need the guided notes, so please make sure you go and grab them. And then let's just quickly review everything we have talked about. So let's say I'm given this kind of equation, right? We know that A is the amplitude, right? And it's a vertical stretch. And we also know, sorry, there isn't a lot of space. We also know the formula to find the amplitude is max minus min all over 2. Now the C is what we call the midline, right? And that means the line y equals c, that cuts the graph in half. And we also know how to solve for that. It's max plus min all over 2, right? And this is also a vertical shift. There's lots that we've talked about so far. What we're going to be talking about today is, okay, if we have an equation like this, sine of bx plus c, we're going to talk about what this b does or what it means, okay? So before we get to that, we're going to kind of talk about some stuff. So if you remember in 8.1, right, we talked about that there are patterns in the sine and cosine curve. And the pattern for sine is 0, max, 0, min, 0, right? And so the length of one of these patterns is 2 pi, okay? So that horizontal length, this 2 pi, is actually what we call the period. So let's define that. So the period is the length of one pattern, right? So in this case, and in a basic sine curve, it's always going to be 2 pi. But sometimes the period can be shorter, right? If it's shorter, maybe the pattern ends at pi, which in this case, it would look like this. The period is way shorter, right? The pattern 0, max, 0, min, 0 now ends at pi instead of 2 pi, so the period is smaller. At other times, the period can be bigger, right? So for example, if it's super large, it may look like this. In this case, it would be off the graph, right? If the period is at 2 pi. So only half the graph is within 2 pi, right? And then the other half is outside, right? Because it's past 2 pi. That means the period has gotten larger, right? It's stretched out. So if the period is smaller, that means it's compressed, it's squished together. And if the period is bigger, that means it's stretched out. So we can write that. If period is less than 2 pi, right? That means it's like this. That means it's compressed or squished. If the period is larger than 2 pi, that means it's been stretched out, okay? Now, along with period, we also care about this thing called the frequency. And the frequency is basically, we'll write this, hopefully you have more space than me, but the frequency is how many patterns are in 2 pi, okay? So for example, 2 pi is right here, right? And in this basic sine curve, there is one pattern, 0, max, 0, min, 0. There is one pattern in 2 pi, okay? So let's say I reduce the period. Let's say I squish it together. So it's like this. And then if I draw another one, I'm finally going to reach 2 pi. So now if we see how many patterns there are, there's one pattern right here, and there's a second pattern. So the frequency, the number of patterns in 2 pi has gone up, okay? So if frequency, so also frequency is actually what we call the B. So this B is the frequency. So I'm gonna use B. If B is greater than 1, that means there are more patterns in the same space. So that means it's compressed. And if B is less than 1, that means there's less than one pattern. So like that would look something like this. Like let's say there's a half pattern within 2 pi. That would look like this. And then it would keep extending on past this. So if B is less than 1, that means it's stretched. So there's obviously a relationship, right? If the period is less than 2 pi, it's compressed, right? If it's more squished together, that means there's going to be more patterns in 2 pi, right? I'll draw that out one more time for y'all. If the period is smaller, so let's say the period is like this, then that means there's going to be way more patterns within 2 pi. Versus if the period is stretched out, or if the period is larger, that means there's less patterns in 2 pi, okay? And so we actually have a formula to model this relationship, and this is the formula. This is important. So period equals 2 pi over B. This is the formula, okay? So let's actually go through some of these problems, okay? So we want to write a sine function that has a midline of y equals c. So if I'm drawing it out, or if I'm writing out the basic equation, I know that y equals 3 is c, an amplitude of 4, that's my a, and the period is 5/7. But here's the thing, you're given the period, which means you need to solve for the b, right? So we're going to use this formula, period equals 2 pi over b. So I'm going to plug that in. So I know the period is 5/7 equals 2 pi over b. So we're going to cross multiply. So I'm going to get 14 pi equals 5b. And if I want to solve for b, I'm going to divide by 5 on both sides. So b equals 14 pi over 5. Okay? So now I can write out the equation, right? So y equals, my a is 4 sine. I'm going to put in my b, which I solved for, and then my c was positive 3. So this would be the equation. Okay? Similarly, this question is saying determine the period of the following trigonometric function. Wow, I can't talk. So here, a pi over 5, we're actually given the b, right? In the equation, we're always given the b. So if we're given the b, we can solve for the period. So I know the b this time. So I'm going to plug that in. Period equals 2 pi divided by, and then I'm going to plug this in, 8 pi over 5. Now watch carefully, right? I'm going to write this out in a way that's maybe a little bit more digestible. 8 pi over 5. And then remember, when we're dividing fractions, we flip the second fraction. So I'm going to have 10 pi over 8 pi. These cancel out, and then if you do 10 divided by 8, math, enter, you're going to get 5 over 4. So the period is just 5 over 4. Okay? Now, let's talk about this stuff. Let's talk about actually looking at graphs, okay? We now know some formulas, right? To find the amplitude, we do max minus min all over 2. To find the midline, we do max plus min all over 2. And so basically, this solid line or the solid graph has now turned into the dotted graph. We want to find the equation of the dotted graph, okay? So first things first, I'm going to find the amplitude, okay? So I know my max is 4. So my max equals 4, and my min is just at 0. So if I plug that into the amplitude formula, I'm going to have 4 minus 0 divided by 2, which is 4 divided by 2, which is 2. So I know my amplitude is 2. Same thing for the midline. I can solve for that. So 4 plus 0 divided by 2 is 4 divided by 2. The midline is also 0. Now here is how you find the b. What you want to do is you want to see what is the horizontal length of one pattern. Okay, so let me look at, this is obviously a cosine function, right? So it's going to be max, 0, min, 0, max. So the max ends at 8 pi. That means the period is 8 pi. So I can plug that into the formula, right? 2 pi, so period equals 2 pi over b. I now know my period is 8 pi. So I'm going to write that in. I'm going to have 8 pi equals 2 pi over b. I'm going to put this over 1, and I'm going to cross multiply. So I have 8 pi over b equals 2 pi. And then to solve for b, I'm going to divide by 8 pi on both sides. The pi's are going to cancel out here. So b equals 2/8 or 1/4. And that is how you can find the equation when looking at the graph. Last thing, I know this is a lot of stuff. This is like it can be very conceptually difficult. What we're going to do now is we're going to practice actually graphing. Okay? It is asking us to graph one cycle of the trigonometric function. Okay? In order to graph one cycle, we need to know what the period is, right? We need to know where the cycle ends. So I am given my b here, which is 3. So again, I have my formula, period equals 2 pi over b. And so I'm going to plug in 3 in for b. So 2 pi over 3. Okay? Now, what I always do is I'm going to count 8 spaces over. 1, 2, 3, 4, 5, 6, 7, 8. And I am going to call this 2 pi over 3. Now, to draw an accurate graph, right, because if you remember, we have our pattern. This is a cosine function. So our pattern is max, 0, min, 0, max. We need to split up the graph so everything is evenly spaced. So what I like to do is draw a dotted line through your period. Then split the space, 2, 3, 4. Split the space in half, like this. And then split each half into half again. Okay? Now what you're going to do is you are going to draw a line at y equals 5, because that is the midline. 1, 2, 3, 4, 5. So here is my midline at a y equals 5. This is where your zeros are going to be. And now, to find your max and mins, you're going to use your amplitude. So you're going to go 4 above and 4 below the midline. Okay, so for example, we start at a max. So at the midline, I'm going to go above 4. 1, 2, 3, 4. And then we have a 0. So at my dotted line, I'm going to make a point at the midline. That's where my zeros are now. Then we have a min. So at the next dotted line, I'm going to go down 4. 1, 2, 3, 4. Then I have another 0. And then lastly, I have a max. So starting at the midline, 1, 2, 3, 4. And then if I connect my points, this is my y equals 4 cosine 3x plus 5. Okay? It's a lot of stuff. We're basically going to spend today and tomorrow doing this. So take your time and ask questions.